Hello, welcome back to this BC1000 battery charger repair, and I have finally figured out what's wrong with it. It's pretty simple, it's pretty obvious. I actually pointed it out in probably either the first or second video and forgot about it and never came back and fixed it, but this is what's going on. We've got the battery charger all hooked up over here, hooked up to the battery pack, and we've replaced the EEPROM in there, or well, we put a programmed EEPROM in it that we got from another, or we cloned from another battery charger. And I've gone ahead and I've got it. Oop, let me go ahead and plug it in. Let me put this back here. Hold on. So I did a bunch of troubleshooting on it. I got it plugged in now, and it doesn't charge the battery. We're going to go ahead and type in menu, hit enter, and then we can go into manual mode. So Shift M goes into manual mode, and then we want to enter in duty cycle, and we want to put it in something really small, like say 5,000. Okay, so this will force it to be PWMing. And this is what I use to do troubleshooting. So there's a couple pins up here which are the pulse width modulation coming out of the pulse transformer, and we can go and, oops, sorry about that, put that on the scope. Oh, you know what, I want the other one because it's triggering on that channel. So we can go ahead and put that up on the screen here. Oh, need to adjust, there you go, there we go. Oh, still not. Okay, there you go. So this is the pulse width modulation, pulse width value that we put in there. Now if you notice, I've got a couple clip leads coming off of here. Those resistors, because this is open emitter, open collector, depending on how you hook it up, and they've got it hooked up with these resistors to ground, and we're able to, so they got open emitter, and we've got, we can look at these. So these will be the A and B PWM values coming out, and I can put those on the scope. But real quick, I was going to say, we've got that pulse width coming through, and if I go to all of these little pulse transformers, I come up this way, and you can see each one of those is pulsing away with those with that pulse width modulation coming out of the PWM controller. I get on all these guys down in here. Kind of hard to do, but you can see they're outputting stuff. So that's what I essentially did. Is this is the microcontroller talks to this PWM chip, which is actually a switch mode power supply controller, and then it goes over to this chip over here, which is a hex inverter, and does some waveform shaping to generate the pulses that go through the pulse transformers, and that allows essentially this one, when it pulses, turns the MOSFET on, this guy turns it off, this one turns on the other guy, and this one turns it off. And then we've got the 6 MOSFETs down here. Every other one is in parallel with it, so these two pulse transformers essentially through the driver circuitry here run every other one of them in parallel, and then this group over here runs every other one in parallel. So what that allows us to do is, I can put that here for a second, and I can hook up my scope probe to these guys, and then we can actually see what's going on. So, got that hooked up just off of these 2 resistors, and we're using this as ground, and that gives us this on the scope. And you can see it's doing push-pull, so this guy's turning on, then this guy, then this guy, then this guy, then this guy. Now if I were to come over here and do a Shift M again, and we're going to change duty cycle, and if I were to type in, say, we'll go full power, this is 14,500 is full power, you'll see those change. Ready, set, enter, and now we're doing 100% duty cycle, and you can see that they don't overlap. They got a little bit of a gap there between the two to allow them time to turn off. So I can go back and tell it duty cycle again, and then we'll just put in, say, like If I put in 2500, you'll see that it actually shuts off. So it goes to 0, and then we can do that again, duty cycle, and say put it back at 5000 because that's pretty light, and it comes back on. So I went through and I traced it from the micro to here, through the pulse transformers, to the gate drivers, and to the actual gate of the of those MOSFETs, and it's all working, 100% working. So everything there is exactly how it should be, but we get absolutely nothing out of the output. So then I started looking around, and I was like, well, in one of the early videos, I mentioned somebody had made a little repair down here at some point. That was not me. I mean, obviously this thing's been repaired before. Somebody pulled out the EEPROM, we don't know why, and they made this little jumper to go between those two connections. And I started getting curious about that, because if you look, you can kind of see how the board is illuminated back behind there. And I know that that 0.015 ohm resistor is the current sense resistor. This side's connected to ground, right? This side's not connected to anything. It's just floating. There is, however, a wire that somebody's bodged on here that goes up to the top. And I thought that was really interesting, because that's going up to the top there where there's no high voltage coming out. And there's no traces on the back. That's not hooked up to any other plane. And so that got me thinking, it's like, wait a minute, is it as simple as whoever did this little repair down here forgot to short both of those together? And what I'm talking about is, let me get something point. Essentially, what I'm talking about is this should be connected to that. It used to be. It used to have a trace like this. This whole thing was a plane, and it got obliterated. And I know that because I've got, if I can find a spot right here, that'll work. I've got pictures. I'll turn this on. There you go. So, if you look at this picture right here, you can see this trace coming up. That's the one that they've replaced with that wire on the back because it got obliterated. But on this, you can't really see it. The power resistor doesn't look like it's hooked up to anything. But on this picture, we can definitely tell that this trace includes it. Right? And they've soldered a wire across from, here to here to finish this gap, because this does go to all goes to these three diodes that we've replaced. And sure enough, I went and put a jumper clip between that little bodge wire and this point, and it started working perfectly fine, which is exactly what I expected to do. So we were really close last time. All we had to do was, if that was hooked up, it would have just worked. So that's what's going on. So all I need to do, everything else on it works perfectly fine. It was just down to that's not connected. So what we're going to do is unplug everything, safely discharge it, and then we're going to go ahead and solder in a bit of wire. It's going to be really hard to do since it's really stuck on the inside of there. And we're going to jumper it back in, and then we'll have a working battery charger again. Alright, so stay tuned for the next episode. It should be working on the next one. It'll be the last part of this series. Alright, thanks for watching.